All right, good morning, everyone. Welcome to Comp 3350 Software Engineering 1. It's even colder today than it was on Tuesday. And it's going to be like minus 35 tonight. And I'm my office, I got to my office this morning and it's 19 in my office. And my thermostat is set to like 23. And the window is not open and I just can't warm up today. And yeah, so I'm sorry I'm like standing here shaking my hands, but my hands are just like frozen this morning. Uh, I want to start by talking about something just completely off topic. This has nothing to do with our course. Like it's barely related to our course, but I thought it was really cool, so I want to show you. Uh, I was trying stuff out with ChatGPT, and I was trying stuff out with some of the stuff that I was doing in Comp 2150. So I've told you about the example that I'm doing in Comp 2150 before, where I'm making like Pokemon classes. It's a, you know, it's contrived, but it's an example that sounds interesting because I'm using interesting words to describe things. And in class on Tuesday, I uh, I ran into this situation. I ran into this situation. I'm trying to write some C++ code where I've got multiple classes and multiple separate files. And I'm making changes to it. And the example that I'm trying to do is like, I want to make a Pokemon. I want to make a new instance of this Pokemon class using stuff that I've received from standard input. I'm trying to demonstrate how to do standard input in C++. And so I start doing it. Here's my main file. This is not at all related to this course, but yeah, welcome. This is the code that I had written. So I've been doing like, C out and then C in and then C out and then C in. And there's the magic with C in where you don't have to like cast to integer or whatever. You just type numbers in and you get numbers entered into the values that you're using. And then I do this on this line right here. I create this new Pokemon that's got a name Bulbasaur, and I try to compile it. And this is what I get as output. And this is the moment where I kind of freak out a little bit and start panicking because I'll be honest. I can be honest with you because I'm not teaching you C++ right now. It's been a long time since I've written C++ code. This is the first time I'm teaching Comp 2150. It's been a long time since I've written any C++ code. So I see this error message and I'm panicking like, oh no, do strings work differently in C++ when you're passing them? So I've got like strings defined in my class. I've taken them in on standard input. Do I have to like pass pointers to strings or something if I'm passing them to this constructor? If you can see what the problem is already, great. If not, don't worry, because I never figured it out in class. I just bailed out. I'm just like, forget it. I'm just going to move on to something else. I'm going to comment this block of code out and figure it out. I immediately figured it out after class. I really did. It's just like in the heat of the moment, I'm just like, I can't do it. I can't figure this out. I'm just like, C++ error messages, C++ compile time error messages. They are the worst. They are just the absolute worst. The problem, if you haven't figured it out, is that in my make file, I forgot to put Pokemon.o here. That's the problem. And the error message is telling me that. It's telling me, like, I was able to compile main. We got past the compile phase, and we're getting to the loader phase, to the linker phase, and there's this undefined reference to this method that you're trying to call. Linker command failed. Linker command fails. That's the hint. That's the hint to me to say, oh, I just forgot to put the dependency in, so it's not compiling it. And I look at the compile command and it's obvious now. It's obvious. Immediately afterwards, it's obvious. There's no Pokemon.o there. There's no method with that name in the compile unit. So let me fix this before I get into that situation again. Okay, but the cool thing that I wanted to show you was, I'm going to copy this. And I'm going to try ChatGPT here. Why am I getting an error like this in C++? Okay, and then I got to copy this again because I copied my password there. And I'll fix it. I'll be polite to ChatGPT here. Okay. Maybe I needed to copy more. Oh, look, here. This is the one that I did this morning. This one was more impressive to me. So this was what I typed in this morning. It's interesting that it's changing. But one thing that's really cool is it's debarfing the error message here, like converting it back to the correct types, which I thought was great. But the thing that it told me is I haven't declared a constructor with that name. The constructor has been declared but not defined in the implementation file. The implementation file is not linked properly with the main file. I can't believe that. I am amazed. I'm really amazed that it's able to, like, here's this crappy C++ error message, and then it tells me a pretty good idea of what I need to do to fix it. I think that's amazing. Round of applause for ChatGPT. Yeah, okay. Okay, so let's talk about software engineering. This is what we actually came here to do. Today, what I'd like to do is reintroduce you to testing. I'd like to reintroduce you to this idea of testing. You were formally or informally introduced to this in a couple of second-year courses. In theory, you were introduced to this in a couple of second-year courses. We are now going to look at this in a little bit more detail than you would have looked at it in those courses. We're going to be spending some time looking at different ways to do testing. So up until now, you've been basically doing one kind of testing, if you've been doing testing at all. We're going to be thinking about several different ways of doing testing. And throughout the course, you're going to be building on this and doing these different kinds of testing. I also want to think in a lot more detail about unit testing. So I want to do things like trying to figure out the right kinds of data we should be thinking about when we're writing tests for our code, the technical labels that we can apply to different kinds of unit tests that we can write. And I want us to see how we can use a testing framework to be able to do that rather than writing test scaffolding ourselves like we would have been doing in Comp 2160. So last class, I asked you this question, why test? And these were the kinds of answers that you, this is not super helpful. This was not super helpful. These were the kinds of answers that you gave to me. So to make sure things work, to save time in the future, to make sure that the code meets the requirements, to address issues, to avoid surprises during production. These are all really good reasons to do testing. I think these are all really good reasons to do testing. I want to state this emphatically. The purpose of testing is not to find bugs. You're not going to do testing where your end goal is to find bugs in your code. That's not the goal. You might find bugs in your code by doing testing, but that's not why you should be doing testing in the first place. The purpose of doing testing and the purpose of doing automated testing is primarily to help you prevent the introduction of new bugs as you're making changes to an existing code base. You're starting to build something individually. So at this point, you're working on iteration 1. You're all sort of working independently. Yes, you have this shared project, but you're all sort of working independently on different things. Very quickly, you're going to have to start making changes to stuff that somebody else on your team has made changes to. One of the primary goals that I have when I'm thinking about testing is to help make sure that the changes that I'm making to somebody else's code don't change what they said that code was going to do. I don't want to introduce new bugs that it's going to change the behavior of what they're doing. It's to show that our product works. This is one of the things that you all came up with, which was really great. And ideally before deployment or delivery. So you're not getting phone calls in the morning left on your voicemail saying, hey, it's not working after you deployed it. There's two major goals that I think about when I'm thinking about testing: verification and validation. Verification to me is, does it work? Does it work at all? So does it get to the point of doing what you think it should do? And then validation is, does it actually do what you said it was going to do? So does it work without crashing? And does it work with the constraints and the requirements that you said you had at the beginning? We're going to be thinking about 3 different kinds of testing in this course. The first kind of testing is kind of the smallest kind of testing, the simplest kind of testing, the most straightforward kind of testing. This is the kind of testing that you have probably done before in some way, shape, or form: unit testing. Integration testing is a slightly more complex kind of testing that tests different things than unit testing does, and it involves more parts of your system than unit testing does. System testing is the most complex kind of testing, and it involves more parts of your system than integration testing does. For iteration 1, your primary focus is unit testing. So doing the same kinds of things that you've done before. For iteration 2, you'll be building on this and doing integration testing. And then iteration 3, you'll be doing system testing. So all the way through the entire system. Let's define what these words are. But before we do that, let's remind ourselves of what our architecture is, because the way that our architecture is structured kind of helps us get a sense of how these different kinds of tests are going to cross boundaries in that architecture. So this is our architecture diagram. This is our high-level architecture diagram that we had when we were talking about architectures. We've got the data model. These are the classes that are related to your domain problem that span across all layers of this n-tier architecture, of this 3-tier architecture. You're using this in every single place. At the front end, this is the part that we are literally touching with our fingers. We've got the presentation layer, and this is what your user sees. This is what they see visually. This is what they're interacting with. This is where they're pressing buttons. We've got the logic layer in the middle, and this is what is making your app your app. This is all the important stuff that kind of says, this is what my app does, and this is encoding all the rules and operations for the system that you've built. And then there's the persistence and data layer. This is where we have our relational database or some other storage mechanism. So in our first iteration, this is just going to be lists and maps, so just in-memory storage. We have separated these layers out. Our goal is to try and make sure that in the presentation layer, this is where all of our Android-specific code goes. We're trying to make sure that we're not doing any kind of logic stuff in the presentation layer. We're not trying to do constraints like duplicate checking, and if we need remove something from our system that has some kind of dependency on something else, that it also gets removed. This is only Android stuff. Our logic layer, we're trying to not include any Android stuff, and we're trying to do not any persistent stuff. Our persistence layer, we're trying to not do any logic or presentation stuff. We're trying to separate all these things out. In between each of these layers, we should have some kind of an interface. So our presentation layer is calling methods that are defined in classes in the logic layer. Our logic layer is calling methods that are defined in the persistence layer. We're okay with this? We're okay with the structure of this architecture for what we're doing? Good, 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 good. Unit testing is asking the question, does a unit of code, does one single unit of code work entirely by itself? independent of everything else that it interacts with. Does it work by itself? A unit, in our case, is usually a method. This is our atomic unit when we're thinking about testing and validating and verifying behavior of a system. It might be a whole class if your whole class consists of one method. It might be a whole class if you have just accessors in your class. It might be a whole class, but typically it's going to be a method. A unit test that's evaluating the behavior of a method is tested entirely in isolation. So there may be dependencies that we have between classes. There may be dependencies that we have between classes. Our presentation layer depends on our logic layer. Our logic layer depends on our persistence layer. The theory of unit testing here is that we should be able to just isolate units in our logic layer and test them by themselves. So verifying that what we're saying our code is supposed to do in our logic layer should show that our code works in the logic layer entirely by itself. Integration testing, then, is stepping it up a little bit, and it's asking the question, I've evaluated units of code by themselves in isolation. Do units of code now work together? This is where we start to span across components and spanning across layers in our architecture. So this is testing the communication between different components. If we've got layers of our architecture here, our n-tier architecture, an integration test is verifying that the logic layer works with our persistence layer. I call a method in my logic layer. It does something with persistence, and I should be able to check that that persistence has actually been made or changed or updated or removed or whatever. I call a method to delete an object in my logic layer. It should call something in my persistence layer. I should be able to verify that that thing has been deleted from the database. I'm now starting to go from just saying the logic layer works by itself, but the logic layer now works with an implementation of the persistence layer. So I'm testing the seams between layers. System testing, then, does the entire application, so from front to back, does the whole thing work when a person is using it? This is now going to be using real dependencies and maybe in the target environment. The code that you're eventually going to be writing for system testing for this project is going to be code that will simulate pressing buttons, literally pressing buttons on the screen. The system tests that you write will push a button on the screen. Your presentation layer will call your logic layer. Your logic layer will do something with the persistence layer. It will all come all the way back up. And then you'll write code to verify that that behavior has been changing something in the persistence layer. So if you're pressing a button here that says add this new item to my system, and it goes all the way through and all the way back, you'll also write code that says check to see if there's a view that lists all the things that I have here. Is that new thing that I just added there? If I've got a button to delete something, if I delete it, I should be able to verify by clicking around in my UI that that thing has been removed from the system. So unit testing, test just this all by itself. Does this thing work without anything? Integration testing, test between two separate layers here. Do these two layers work together? System testing, my arms aren't that wide, but click on buttons, have stuff happen in the back end, and then verify that those changes have been made by clicking around in your application as though you were a user actually using the system. Okay, so here's our first activity. This is the first thing I want you to do. Here are a list of descriptions of tests. What I want you to do is, with your team, try to classify what kind of test this is. So this is some kind of thing that I want to verify in my system, and I want you and your team to decide what kind of test this is: a unit test, an integration test, or a system test. I'm going to give you, I don't know, 5 to 6 minutes to work on this, and then we'll classify them together to make sure that we're all on the same page about what I'm thinking of. But the approach that I want you to take here is this something that should be tested by itself? Is this something that's testing across 2 layers? Or is this something that's testing the whole system from front to back? Okay? Okay. I'm going to put 5 minutes or so on my timer, and then we'll come back together and we will talk about it. Please go ahead. All right. So let's talk about these different kinds of tests. Let's talk about these different tests and try to decide what kind they are. So what I'm going to ask is, here's what I'm going to ask. I'm going to ask you to put up 1 finger for unit, 2 for integration, and 3 for system. So for test number 1 is, does the video encoder give the correct bit rate of a video file? Is that a unit test, an integration test, or a system test? Everybody, please. Everybody. Good. I also agree. I think that is a unit test. The video encoder is operating entirely by itself. We're not really depending on anything for this. We're assuming that the video decoder implements video decoding. We're assuming that. If we're depending on something else, then maybe we could call this an integration test. But because we didn't really say anything about that, we can just assume that this is a unit all by itself. So good. Number 2, is this a unit, an integration, or a system test? So I'm seeing lots of system. And some integration. In this specific context, I'm going to agree with system. I'm going to agree with system here specifically because of the word appearance, specifically because of that word. This statement is implying to me that I'm literally looking at a screen to decide whether or not it has shown up there. So a content creator is uploading a video. Does it appear in the right genre? I'm imagining this as being, I'm uploading a video on one screen and then switching to some other screen to see if it shows up in the right place. So I'm going to cross this off, and I'm going to say that this is a system test. Number 3. Oh, yes. Yes, please.
Interacting with the system, would you think that like normally goes on the system testing, because we're like kind of using it from the beginning, like from the interface, right?
Yeah. So that's a good strategy in this case. Is if you see that the user is interacting with this in some way, it's almost certainly a system test. Yeah. So number 3, what do you think? System, unit, integration. Everybody, please. Everybody. Okay, 2, good. I agree. I think this is an integration test. We've got a video processor manager. So this is a name to me that implies that it belongs in the logic layer. We're asking about its interactions with the persistence layer. So we're testing a seam between 2 layers of our application, and that's it. Number 4, when a user flags a video as inappropriate, does it show up in the administrator console? Everybody, please. Everybody. Okay, good. Excellent. 3, I believe this is a system test. So it's user interactions, yes, but there's a couple of other things that say to me that this is a system test. The first one is, does it show up in the administrator console? Okay, so that's kind of implying to me there's some UI for that. The other thing that flags this to me as a system test is that there's 2 users involved in this test. One is we've got a regular user flagging a video, And then the other one is we've got an administrator. So that implies to me that to do this test, we have to log in as a user or log in anonymously and no login, click on something, log out, log back in as an administrator and test to see does that actually show up in the place that I was expecting it to show up. Number 5, does the video recommender suggest similar videos provided a video? What do you think? Everybody, everybody, everybody. So I'm seeing a good solid mixture of this. Okay, that's great. No, that's great. This could be an integration test. It could be an integration test. It could be an integration test because the video recommender to me is a logic thing. This is what makes our app our app. Given a video, so we're providing input to this, is it able to recommend other videos to us that are related to it? It's reasonable to say that that is spanning across both the persistence layer and the logic layer. It's very reasonable to say that. I would say that this is probably not a system test. Probably not a system test because it's not really like clicking on a video to see if there's a list of recommended videos. If you interpreted it that way, then sure, yes, it's a system test. But as stated, to me, this is not a system test. We're not actually invoking the UI in any way. To me, this is probably more like a unit test than anything. And the reason I'm saying that is that, yes, you are right. And I don't want you to think that I'm completely disagreeing with you. Given the right setup, this is an integration test because you're interacting with the database. But I'd say that this is a unit test because we can isolate the database away from this unit. The question that we're asking is, does the video recommender give us recommended videos, the correct recommended videos, or things that are related to that? And we'll see this later in the course. This is why I'm not just like shutting it down right away, that this is not an integration test. We'll see this later in the course, but we can actually take these dependencies that we have and we can create fake things that represent those dependencies. And the goal is to isolate the unit by itself. So if the logic here is get all the videos in the database and then just find the ones that are related, which would be a terrible design, but just go with me for a second. If that was the way that it worked, I'd say that this is a unit test. We can just take the database end off of that, provide the correct output from the persistence layer to this unit, and then just test the unit in isolation. In the state that we're in right now, I'd say we can say that either is correct. And the last one, does the payment processor validate credit cards correctly? What do you think? Okay, good, thank you. So primarily units. Some people are saying integration, and that's okay. I'm going to say that this is, it's definitely a unit test. So we're just validating credit cards. We're validating credit cards like using properties of the credit card itself. If you want to imagine this as we're actually asking Visa, is this a real credit card? Like we're trying to push a purchase through on this thing. That would be a system test more than an integration test because it's not just two layers that are interacting anymore. Now you're involving some external service that's entirely outside of your application. So I'd say that this is the best described as a unit test. All right. We're all good with this? Any questions? Yeah. Yeah.
It has to be validated from somewhere, right? So the data has to be included in that according to or with the logic. So I feel it's kind of integration.
So I'm going to restate what you said just to make sure I got it. You're saying that it kind of has to be an integration test because you have to get that validation data from somewhere.
Yeah.
So This is a case of maybe me knowing something that you don't know about credit cards. And when I say validate a credit card, I just want to make sure that it's a credit card that passes certain checks. And the checks are, does the checksum for this credit card actually give it a valid credit card number? And that's different. And so this is kind of what I'm saying about making, maybe this is a system test where you're involving that third-party Visa. You can do a checksum on a credit card just by inspecting the digits in the credit card. Yeah, 16 digits. There's also this thing called the LUN algorithm, L-U-H-N, for validating credit card numbers. And it's just like you take all the digits in the credit card. I forget the way to do it, but it's a way to isolate just the number itself and say this is a valid credit card number based on what's been put in here. So maybe to put this into a visualization in your head, you've all used credit cards online before? Yes? Thumbs up, please. Yes? Okay, good, good. And what credit card did you use to enter your information? Okay, good. You're not telling me what credit card numbers are? So sometimes when I enter my credit card number in, it will very quickly like switch to say Visa, or it will switch to say MasterCard very quickly. And there are no web interactions there. That's just the UI like looking at the numbers that are in the credit card and then quickly deciding this is or is not a Visa or a MasterCard or whatever. That's entirely in your browser. There's no external interaction there. Similarly, when it's doing basic checks like, is this a credit card number? It's doing it entirely in your web browser. It's not asking Visa or Stripe or whatever to check this number. It's just doing it entirely within the system, so it doesn't have to send anything around. So you have a good point. I want to make sure that you get that. Your point is good. Your point is valid. And this is more something that maybe I know that you don't that's changing the answer that I have for this. Yeah, yeah.
Passing the payment through within the integration?
It would then be integration or system, yes. I'd say that it's closer to system than integration, though, because it's starting to rely on systems that you don't even control anymore. And because they're systems that you don't control, they're not seams between architectural layers that you have. They're like different things entirely. They're completely separate applications. Good. Okay, great. Let's move on. So you hopefully have a sense of what unit testing is. It might be kind of fuzzy right now because it's been a long time since you talked about it. It might be kind of fuzzy because it's just fuzzy still. That's okay. I want us to start thinking about unit testing, and I want us to classify kinds of unit tests. I'm going to be expecting you to write different kinds of unit tests, so I want you to see what those different kinds of unit tests, what those different kinds of unit tests are called and look like. Before we talk about these two types, black box testing and white box testing, and just for transparency, white box testing is also sometimes called clear box testing. So if you've seen these terms before, you might have seen clear box testing instead of white box testing. Clear and white box testing to me are synonyms of each other. Black box testing, I've never seen another name for that. Before we talk about that, I want to spend some time talking about interfaces and implementation. This picture, we all know what this is? Does anybody know what this is? Graphics card, GPU, good. There are two parts to this. There's two parts to this. There's the plug part, this thing, where you're plugging in your monitor, your display. This is kind of an old video card. You probably don't have DVI on your video cards anymore. But this is a plug where you plug something in. And then you've got the actual GPU. This is like a bunch of tiny little processors all jammed together onto one die, and they're doing vertex crunching rapidly, very fast. There's two parts to this. This part here, and going down this way, this is the interface to this card. we've got a monitor, like there's a nice prop here. There's an actual literal monitor here. This monitor doesn't know anything about how that video card works. It doesn't know or care anything about how the video card works. The only thing that that monitor cares about is that the interface that's provided by the video card is satisfied. There's a plug, there's quite literally a plug that I can jam a wire into, or there's an adapter that I can plug into this thing. And the signal that comes out of here is like whatever that display needs to show. That's all that monitor cares about, is it's depending on that specific interface. You're doing gaming, you're mining Bitcoins, I don't know what the kids do these days. You're doing something and you decide to buy a new video card and you switch from NVIDIA to AMD. You don't buy a new monitor. You don't buy a new monitor because the monitor that you've got depends just on the interface that is provided by this card. The implementation of this card is here. Everything else that's on this PCB. Primarily this. This is the thing that generates that signal and spits it out on those interfaces. But your monitor doesn't know anything about that implementation. Your operating system has to know something about that implementation so that it can drive the video card and tell it what to do. Your monitor doesn't know anything about the implementation. It relies just on what is defined by the interface itself. Closer to our practice, closer to our hearts. An interface in Java literally is an interface type. It defines only what the methods in a class can do, and it doesn't define what they do. There's no implementation here. In C, you've hopefully seen something that looks like this, a header that has a type def, and then functions that you pass instances of that thing to. These tell us only about what the class can do, not how it does it. Our implementation, so in Java, implements an interface. This is actually defining the implementations. So I have this interface that has been defined for me, and I have an implementation of that method under here. I've got code that does what that interface says it's supposed to do. Black box testing. So let's talk about testing now. We've got interface and implementation out of the way. Black box testing is testing to just the interface. We're testing the behavior that is stated by the interface. So we've got a DVI port on our video card. We've got a signal that comes out of that DVI port. We're checking to see if that signal that comes out of the DVI port is a valid signal that can be displayed on a monitor like this. There's no concept of how the code is implemented, just what it should do. This method says it's going to do this. I'm going to test if it does this. I don't know if there are conditional branches. I don't know if there are loops. I don't know what kind of data structures are behind this. I am only testing that this method says it's going to do this, and that's it. That's the only thing that I'm doing. White box or clear box testing is testing the implementation of a unit. In this case, we're just like looking at the code. This is the implementation of this method. I can literally see all of the paths that this code can take. I can see all the conditional statements. I can see the loops. I can see the data structures. Where black box testing is testing just to the interface, white or clear box testing is now saying I can see everything. I can see every path through this. I can write tests that will make sure that this condition is satisfied and this other condition is also satisfied, so that I can show that the behavior is correct in both of those cases. Okay, we're going to come back to this idea in a minute, but I want to move on to like testing frameworks. We okay with this? Black box, clear box. Good, good, excellent. When you were doing testing, okay, I need to ask because I don't know who you took Comp 2150 with. Did you use JUnit in that class? How many people have used JUnit before? Most people, okay. So this might be just a little bit of review. It might be a little bit of review. It might be new to you. Either way, I want to step through this to make sure that we're all on the same page, because I might be telling you about stuff that you didn't use in Comp 2150. Everything that I'm talking about here should be represented in the sample project. So all the features of JUnit that I'm talking about here should also be represented in the sample project. We're going to be using JUnit. We're going to be using a testing framework for testing. So we are going to be writing a bunch of test methods to evaluate behavior, but we're not writing a main method. We don't have to write that scaffolding. We don't have to say run all of these tests. We're just going to write the tests. And we're going to let the framework run the code. So JUnit is a framework that has been written that will take a bunch of classes that you've defined and written in a specific way, and it will find all of the tests in there, and it will run all of the tests for you. So you don't have to go through that painful process of writing this main method that just calls a bunch of other methods and doesn't do anything else. Really broadly, when you're doing JUnit tests, you're using assertions to evaluate behavior. And the primary change that you should make, or the primary change that I suggest that you make, is to do a static import of these assertions. This is the same as, or this is approximately the same as, so if you remember C++, this is approximately the same as saying using namespace std, and then not having to type std : everything that you want to use. Import static here says take all of the methods that are defined in this assert class, and they're just in my class. I can just call those methods as though they are there, as though I have written them. You are going to write tests. You're going to write unit tests, and then you're going to annotate tests with this test annotation. At and then test. This is also a class that you'll have to import. Your IDE and IntelliJ Android Studio should help you import classes that you need as dependencies. That marker there tells JUnit this method is a test, and it should be picked up when you try to run tests using JUnit. When you create classes for tests, you should name them in a specific way, so they should have this suffix test. Again, this helps JUnit pick up that these are classes that contain test methods and that it should pick them up. When you are creating test classes, my suggestion is that there should be one test class per class. So if you have a logic layer class, you should have a corresponding test class for that logic layer class. You shouldn't like constrain yourself to that. If you feel like you need to split it up into different classes, go for it. But there should be at least a one-to-one relationship between the actual code that you've got and a test class that corresponds to it. When you're making assertions, this is where you're going to be verifying that the method does what it says it's supposed to do. It gives you back the results that you're expecting, or the changes that you're expecting happen. There are many different assert methods that you can call. Assert equals is probably the one that you're going to call frequently, but there's other things like assert true and assert false. You should check out the JUnit documentation to see what the comprehensive list of assert methods are that you can call, so that you can pick the right one when you're writing code with it. The first argument that you pass to all of these assert methods is a message, and I am going to insist that you put a message in every one of the assertions that you write. The messages that you write in there are helpful because they're documenting what you're testing. So as opposed to just saying assert equals this, you're saying assert equals this is why I'm testing this, and these are the things that I'm trying to check. But when you do get test failures, it prints the message out. So it actually gives you a better sense of what it was supposed to be expecting, not just, assert equals, not equals. You figure it out. These should be equals because of X, or they should be equals in this situation because I've done this to them. There are also two annotations that you can use to run before a test and to run after a test has happened. So the before and after annotations, you can put on these methods. The name of the method doesn't matter. All that matters is that you have the annotations on them. Before runs before every test. So the before gets called, then your test gets called, then the after gets called. Then when the next test starts to run, the before gets called, that test gets called, and then the after gets called. And then before the next test runs, the before gets called, and so on. So before every single test, this is going to happen. This is useful. The before method is useful for setting up data that you might have that you're expecting to be in, for example, a stub database before the test that you're actually running finishes. And the teardown is to make sure that you're cleaning up after that test has finished. So if you're making changes to something that's shared between two tests or shared between two objects in the system that you're testing, the after method should be used for making sure that everything is kind of put back into the state that it was before you started doing testing. The tests that you write should be independent from one another. This is true of all of the kinds of tests. So system test, integration test, and unit test, every individual test should not rely on another test having happened before it. It shouldn't rely on happening after another test has finished. So what I mean by that is, if you have a test add thing, you shouldn't be relying on that test add thing having happened before other tests that you're writing. If you're expecting that to have happened, you should do it in the test that you're testing. So test add might be a unit in and of itself. The next test should also add that thing that you're trying to add and then remove it after it's finished so that we're back in the same state that we were in before the tests started running. The tests that you write should be minimal. They should be quite small. This might mean that you have lots and lots of test methods. That's okay. Code it's basically free. It's basically free. It takes a little bit of time to write, but it's basically free. Just like when you're thinking about writing classes and logic and everything else, your goal should be to have one test testing one thing, and that's it, trying to isolate one behavior as much as possible. That often means that you have one test testing one piece of data, and that's it. Every method that you have written in your logic may have many tests that are attached to it. So thinking about both white or clear box tests and black box tests, a single method may have different behaviors that you're trying to check. So a credit card validation might be test that this is valid and test that this is rejected. Those are two independent tests from each other. They're not part of the same unit. So you may have many different test methods. If you're finding yourself in a state where you're writing a test and you have to do a lot of weird setup, or you're in a state where you have written a lot of testing code and it's very brittle, like every time you make changes to your code base, that test suddenly fails and you have to change it or rewrite it. Complicated tests imply that you have complicated code. You've got to spend a lot of time building up a test. The code that you're testing is also probably more complicated than it needs to be. If you're finding yourself in that situation, my suggestion is that you should be refactoring your code and simplifying your code. Refactor is a word that I haven't used until right now. We will use it more later in the course. But the idea here is, if you're going through and testing your code and you're finding that the test is very complicated, then using your code in other places is also probably very complicated. Using it in the presentation layer is also going to be just as complicated as it is writing the test that you're writing right now. If you're finding yourself in that state, then change your code. Refactor your code is a complicated way of just saying change your code. Make it so that it's less complicated than it is right now. Spend some time thinking about it. Okay, so thinking about black box tests and white or clear box tests, and thinking about JUnit itself, what I would like you to do is write some test data minimally, and maximally, I'd like you to start writing some tests. The option that you have here, the unwritten option that you have here is, if you have code already, if you've started writing code for your own project that is reasonable for you to start testing, then don't test what I put up here, but start thinking about writing tests for your own code. But I want to make sure everybody has something. What I'd like you and your teams to do here is spend some time coming up with test data. So black box data and white or clear box data. And then maximally write a JUnit test. So type it up or like write down some kind of pseudocode that represents what a JUnit test approximately looks like. Here's the code. This is the code that I want you to test. Again, if you have reasonable sized code for your own project to test, do that instead. But if you've got nothing, use this. I'm going to give you 5 or so minutes to come up with some data. I'm not super concerned if you can write the tests with JUnit or not, because you'll have lots of experience doing that. I'm much more interested in the actual data that you come up with. So please go ahead, come up with some test data that's black box data, testing just the interface. Come up with some data that is clear or white box data and test the implementation. Please go ahead. All right. So let's get back together here. I'm going to ask randomly here. Team member 5. You're in the hot seat. You're in the hot seat. What kind of black box? So first of all, did you do this test case or did you do something for your own code?
We did this.
Okay. So what kind of black box data did you come up with?
Some kind of stuff that we had like kind of a happy path where everything's valid and good.
Okay.
We also had some stuff where either the number they expired in CDC would be like an invalid format. Maybe
Okay.
like EDC, whatever.
Okay. So I'm going to ask you to stop for a second. So if we've got valid card data, what is the expected output for this? What would you assert?
Assert true.
Okay, so if you have valid data, you're asserting true. And then I'm gonna generalize. I don't want to put words in your mouth, but I want to generalize. Everything else you're describing is invalid data, right?
Yes.
Yeah.
And those would all be like separate tests. It would be just one test.
And I'm assuming that your expected output here is false, right? So invalid here, you're describing things like CVC. Invalid here might be expiry date. Invalid here might be the card itself. So it's got like letters too short, or whatever, stuff like that. Yeah?
Yeah.
That's good? Good. I agree with you. Based on our interface, there are 2 outcomes. There's just 2 outcomes. It's just a Boolean. It's true or false. That's it. Those are the only things that we can get as output from this thing. We know what a credit card number is. We know whether it's valid or not. That's it. That's all we can test from this method. So we can send in some valid credit card data. Maybe that means like, yeah, whipping your wallet out and getting your card out and typing it into this method as input to see does it return true for this? And then maybe making changes to this to say, does it return false? I'm going to ask you, Team 5. I'm going to ask you. Did you say null?
Oh yeah, I thought it, and then we started talking about it.
Okay. Okay. I'm just going to leave that to hang over everybody's head, and I'm not going to say anything more about it for now. I'm just going to leave null question mark. That's it. Team number 4. Team number 4. Okay. Team number 4. Just give me one example of clear box data that you came up with. Okay, so that's 2 tests. That's great though. That's 2 separate tests. So the first one you have is starts with a 4, and the second one you have is starts with a 5. And we can do this because we have the ability to see these 2 code paths, right? We can see that conditional statement here for 4, the conditional statement here for 5. I'm going to build on what you said, and I'm going to say that there's actually 2 or more paths for each of these now. From here, there's valid and then true. And then there's also all of the invalid cases. And all of those should return false. Similarly, there's 2 paths after the second branch. We've got valid, and we're expecting true to come back from that. And we've got invalid, and we're expecting false to come back from that. Did you get to that point? It's okay if you didn't. It's super okay if you didn't. Okay. 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 The tests that you have for black box testing can inform the kinds of tests that you're doing for clear or white box testing. They can help guide you and supplement the paths that you're taking through the conditional statements or the loops or the data structures that you're using in the implementation that you're actually testing here. Was there anything else that any other team came up with that, that we've missed here? Yeah. Okay, good. So starts with anything else. I'm going to say here 1 to 3 and 6 to 9, I guess. And this should be a 0 to 3. So it starts with any of those ranges. And those should all be false. Good. All right, great. So we've come up now with some test data. What I would expect you to start doing with this, not literally this, but with this idea of black box data and clear or white box data, is to take each of these cases that we have defined here and start actually creating JUnit tests that correspond to those different paths, different sets of invalid or valid data that we've come up with. That's what my expectation would be. When I'm thinking about writing tests for my own code, this is the strategy that I'm usually taking. What is the data that I want to evaluate? And then actually writing the tests to do that evaluation. I'm going to finish up here because we're just running out of time, but I'm happy with where we've got. I'm going to ask you all to agree with me. You don't have a choice here. Testing is good. Testing is excellent. Everybody put your thumb up. Yes, testing. We are going to love testing so much. But you can't usually test everything. My suggestion would be come up with a representative set of test cases in the 2 main categories that we've described here. valid data and invalid data. Valid data is that happy path. So this team 5 used this word, happy path data, the simple data, and then some kinds of edge cases that you might have for your system that are valid. Edge case data is data that looks weird, but is still valid. Typically, the typical edge case data that you can be thinking about are things like empty strings or lists that don't have elements in them. There's an object that represents a list, but there's nothing in it yet. Invalid data is data that is structured correctly, so it's the right type. If you're expecting a string, it is actually a string. You're not trying to pass an integer into something, but it doesn't satisfy the constraints that you've got. A more complex example of that is that you've got a user object with a password that doesn't satisfy the password requirements that your system has. Invalid data is data. It is data. It's not null. This is what we're going to start with next week. I'm going to leave you with this question, though. I want you all to think about this. Should we test for null? That's where we're going to leave this week. Should we be writing unit tests, integration tests, and system tests that are testing null? That's it for this week. Thank you for coming out. I hope you have a great weekend, and I will see you on Tuesday.